Engineering route surveying. Engineering route surveying is a survey for the design and construction of linear works such as roads and pipelines. Route surveys establish the location of transportation routes such as highways and roads, railways, rapid transit, canals, pipelines, and transmission lines. Route surveying. Route surveying is the function of the project survey or to plan the survey and collect the survey data needed to plan and lay out the final design. This will include planning and establishing horizontal and vertical control, topographic surveys, construction surveys for design location, and route surveys include both horizontal and or vertical plane surveys.
So we have now the purpose of route survey. So why is route survey required? So first and foremost, it is to ensure the safety of motorists traveling over the roads and highways. So also to protect public assets and property from being damaged by an extra large or heavy shipment. So this is why the laws governing the shipment of extra large and heavy loads are so strict. As they prepare to expand services in new area, governments or businesses will order a route survey. So the surveyors will meet with the representatives to discuss plans such as the amount of lanes in a roadway or the kind of utilities that will be installed throughout a region. So this information will be useful for planning because surveyors must consider the project's parameters. So on the route survey, the surveyors utilize a range of tools to profile the landscape, paying close attention to geologic formation, property lines, and other things that could cause a problem. So we have here two ways to solve a route survey. We have horizontal and vertical survey. Vertical curve. So we have here the horizontal curve. Horizontal curves are used to adjust a road's direction or alignment. Circular curves or circular arcs are example of horizontal curves. So as the radius of the curve decreases, the sharpness of the curve increases, so making it unsafe and dangerous. So the availability of a sufficient safe stopping sight distance is the primary design criterion for a horizontal curve. So what is the difference between the horizontal and vertical curve? So ang vertical curve is ingani ang iyahang picture. Kumbaga, mura siya naay pasaka, naay paubos, pero angaton siya nga naay pa-curve, paliko-liko nga naay pa-curve. So yung ani ang iyahang vertical curve. Whereas kung sa horizontal curve is flat lang ang iyahang road, flat lang ang dalan niya, pero naagya pon say paliko-liko. Mara siyang difference. Ang vertical is ang pasaka panaog, ang horizontal is like flat lang. So what is the purpose of kani? What is the purpose ng nganong magtuon ta og horizontal curve? Nganong need pa nato siya i-solve ang pagkuan ani niya? So horizontal curves are one of the most important elements in a roadway geometry design. So the main function of a horizontal curve is to provide a smooth transition between two tangent roadway sections to ensure roadway driving consistency. So we refer to this example diari sa kuan. So kung ani ka sharp ang iyahang curve, ang palikuan ni niya, so for example, ang driver paspas kayong mudagan. So kung ani ka sharp ang iyahang curve, of course, dugay kay siya ka kanang murag dugay kayo ang iyahang reflex muliko, mudritso siya pa straight, 'di ba? Ana siya. So muna ang kailangan nato siya i-solve para to ensure nga walay accidents mahitabo, makaliko og tarong, consistent ang iyang pag-drive, walay paspas, walay kuan, walay paspas, walay hinay. So kung para kung makaliko siya, liko na siya diretso. Wala na yung mga kuan problema kung sa pana siya.
One type of a horizontal curve is the simple curve. A simple curve consists of a single arc of a circle connecting two straights. It has a radius of the same magnitude throughout. In order to construct a simple curve, we need to form two tangent lines. So, mauning duha. The line formed is known as the tangent distance. Basically, it is the distance along the tangents from the point of intersection to the point of curvature or to the point of tangent C. Bale, these distances are both equal. The angle created by these two tangent lines form an eye angle or the central angle. It is also called deflection angle, as you can see in the figure. So it is equal to the angle formed below by the two radii drawn from the center of the arc to the point of curvature and point of tangency. So, naa sa diri central angle. The point from the left tangent line, kani, is what we call the point of curvature. It is where the circular curve begins. The back tangent is tangent to the curve at this point. Meanwhile, the other point found in the right tangent line is known as the point of tangency or the end of the curve. The forward tangent is tangent to the curve at this point. Moreover, the point of intersection, kani sa pinakatop, marks the point where the back and forward tangents intersect. So from these 2 points, the point of curvature and point of tangency, down to 0 or the center of the arc, we form 2 lines as well. So these separate lines are what we call the radius. It is the radius of the circle of which the curve is an arc. Take note that the radius and the tangent line, as you can see in the figure, are perpendicular to each other. So connecting the points from the point of intersection down to the center of the arc or the 0, we eventually divide the figure into 2. Di ba makita? Makita ninyo na ma-half siya? So meaning the central angle located below will be divided into 2. So making the equation I over 2. Same goes for the long chord, kaniman, which gives us an equation of C over 2. So the next element that you can see is the long chord. It is the horizontal line present from the point of curvature to the point of tangency. Also, there is a curved line above the long chord. This is called the length of curve. It is the distance from the point of curvature to the point of tangency measured along the curve. We have the external distance as well. Here, kani. It is the distance from the point of intersection to the midpoint of the curve. The external distance bisects the interior angle at the point of intersection. On the other hand, the middle ordinate is the distance from the midpoint of the curve to the midpoint of the long chord. The extension of the middle ordinate bisects the central angle. Lastly, the degree of the curve. So, the degree of the curve is not stated or indicated in the figure, but it is simply a line from the center of the arc to the length of curve. So it has a standard length of 20 meters and it defines the sharpness or flatness of the curve. Now that we already know its elements, we may proceed to its basic formulas. The formulas were derived simply by using the simple trigonometric function or the SOHCAHTOA. Since we know that the radius and the tangent line are perpendicular to each other, from here we can form a right triangle. So the relationship of the tangent to our angle I over 2 is opposite, while the radius to the angle is adjacent. Therefore, we will use the TOA. So tangent of I over 2 is equals to T over R. To find the radius, we get the formula R is equals to T over tangent of I over 2. So this is our formula for our radius. However, to get the formula of the tangent, we have T is equals to R multiplied by tangent of I over 2. Next is to get the external distance. So based from the right triangle, our hypotenuse would be the radius, kani, minus, plus rather, the external distance, while the radius alone would be the adjacent. meaning we will use the ka. So cosine of I over 2 is equals to r over r plus e. So r plus e is equals to r over cosine of I over 2. Transposing r to the other side will give us e is equals to r over cosine of I over 2 minus r. Finalizing the formula, we get e is equals to r multiplied by 1 over cosine of I over 2 minus 1. Next is the middle ordinate. So the relationship of our r minus m to our angle is adjacent, while the radius to the angle is hypotenuse. Therefore, we will use the ka here as well. So cosine of I over 2 is equals to r minus m over r. R minus m is equals to r multiplied by cosine of I over 2. Transposing r to the other side, we get m is equals to r minus r multiplied by cosine of I over 2. Finalizing the formula, we get m is equals to r multiplied by 1 minus cosine of I over 2. So for the chord, we have c over 2 or l over 2 as the opposite and r as the hypotenuse. Kani. Hence, we will use the saw. So sine of I over 2 is equals to c over 2r. Finalizing the formula, so c is equals to 2r multiplied by sine of I over 2. So let's proceed to the length of the curve or the arc length. Since the arc length is part of the curved circumference, in this case, we can apply the ratio and proportion. Take note that the circumference of the circle is 2 pi r with 360 degrees, diba? Divided by half, we get a semicircle with the circumference of pi r and an angle of 180 degrees. So applying the ratio and proportion, we get L over I is equals to pi r over 180 degrees. Therefore, our length of curve is L is equals to I multiplied by pi r over 180 degrees. Next is the degree of curve. Basically, it is just a part of the arc length with a standard length of 20 meters. Hence, we can also apply the ratio and proportion in this case. So L over I is equals to 20 meters over D. Or simply L is equals to I multiplied by 20 over D. This formula, however, is only applicable when the degree of curve is given. Take note if the degree of curve is given, but if not, we will use the previous one, kani. Okay, so we then equate the 2L, this one and this one, giving us an equation of I multiplied by 20 over D is equals to I multiplied by pi r over 180 degrees. Cancel I, we get R is equals to 20 multiplied by 180 degrees over pi D, which is equivalent to R is equals to 1145.316 over D. Now that we already know its formulas, let's try to solve one problem. A simple curve connects two tangents AB and BC with bearings 84 degrees northeast and 65 degrees southeast respectively. If the stationing of the vertex is for 362 and the stationing of BC is for 285, determine the radius, the external distance, the middle ordinate, the chord distance, and the length of curve. So creating the figure of the simple curve, we have 84 degrees northeast at point A and 65 degrees southeast at point B. For the point of curvature, we have a station of 4 plus 2, 85, and the stationing of the vertex or the point of intersection, 4 plus 362. Now that the given values are already in place, we may proceed in determining the radius of the curve. So as what I've mentioned earlier, point A has 84 degrees northeast. So if point A has 84 degrees northeast, bali same siya diri na part. Pao na ay 84 degrees diri. So, computing for the central angle, so I is equals to 180 degrees or the whole angle diri na part minus 84 degrees, minus 65 degrees. So we get an answer of 31 degrees for our central angle. If we divide it by half, we get 15.5 degrees. Therefore, this will be our value for I over 2. So for our tangent line, since we have the given values for stationing, which are 4 plus 362 and 4 plus 285, this is what we will use to get the answer. So t is equals to 4 plus 362 minus 4 plus 285. We get an answer of 77 meters. So substituting these values to the formula of the radius, so r is equals to t over tangent of I over 2, or simply 77 meters over tangent of 15.5. So we get an answer of 277.563 meters. This is the answer for the first part. This is now our radius. So to get the external distance, we use the formula E is equals to R multiplied by 1 over cosine of I over 2 minus 1. So R, or 277.653 multiplied by 1 over cosine of 15.5 minus 1 is simply 10.749 meters. This is our external distance. For the middle ordinate, we have the corresponding formula of m is equals to r multiplied by 1 minus cosine of I over 2. So substituting the the values, so r, or 277.653 multiplied by 1 minus cosine of 15.5. So our middle ordinate is 10.098 meters. For the chord distance, we have c is equals to 2r multiplied by sine of I over 2. So 2 multiplied by the radius, or 277.563 multiplied by sine of 15.5, we get an answer of 148.399 meters. Lastly, determine the length of the curve. So since the degree of curve is not given, we will use the formula L is equals to I multiplied by pi r over 180 degrees. So 31 degrees, diba? 31 degrees is our central angle, multiplied by pi, multiplied by the radius, 277.653, divided by 180 degrees. Therefore, the length of the curve is 150.225 meters. So that's it for our simple curve. Let's proceed to another type of horizontal curve, which is the compound curve.
Next is we have a compound curve. So a curve is made up of two or more circular arcs of successively shorter or longer radii joined tangentially without reversal of curvature and used on some railroad tracks and highways as an easement curve to provide a less abrupt transition from tangent to full curve or vice versa. So in simple terms, compound curve consists of two or more simple curves with the same bending direction and with different radii. So here is a representation sa compound curve. It says here na it consists of two or more simple curves. So this one right here is the first simple curve. Kani, first simple curve. This one right here is the second simple curve. And then, it says here also na it has the same bending direction. So, kung ang direction ani niya, padulong diari, o padulong siya sa right, of course, sa right po siya mo, padulong po ng usa ka curve niya. Dili siya mo go sa opposite direction. Kung sa opposite direction man gali na siya, that is what we call the reverse na. So, karon compound man ta, so yung ani ang iyahang concept niya. And with different radii. So, pareha ani, ato ang radius nato is shorter than atong first radius is shorter than our second radius, or either way pwede pud siya ato ang first radius kay mas taas kaysa sa ato ang second radius. So that is the concept of our compound curve. Next is we have the elements of a compound curve. First is we have the point of curvature or the PC. So ang PC nato is located right here. This is where our circular curves begin. So diri magsugod ang atoang curve na to sa point of curvature. Next is we have the point of tangency. And diri sa last, this is where our circular curve ends. So diri mag-stop ang atoang curve sa point of tangency or PT. Next is we have the point of intersection or the PI ana dali sa taas. The point of intersection marks the point where the back and the forward tangent intersect. So, kung mag-intersect ang ato ang back and forward, kung asa mag-intersect ang ato ang back and forward tangent, diri ni siya located. Ang ato ang back tangent is kani nga linya, kani. Mo ni siya. Kani nga linya ang ato ang back tangent. And then this one, ang kani nga linya, mo ni ang ato ang forward tangent. So, kung mo straight na siya, kung asa na sila mag-meet, dira ang ato ang point of intersection. Next is we have the PCC or the point of compound curve. Nasa dari. It is the point when the two curves connect. So, two curves connect. Kung muna ato ang first curve nato, mo na yung ato ang second curve. So, atong PCC is na adi-ari. Kung asa nag-meet ang duha ka curve. Next is we have T1 and the T2. This is the length of the tangent of the curve. So sa T1, it is the length of the tangent of the first curve. Kani ang ato ang T1. Mo ni siya. Mo na itong T1 ato. Kani. Ang T2 is the length of the second curve. Kani. Mo na yung ato ang T2. Kani nga part. So we have the V1 and the V2, the vertex of the first and the vertex of the second curve. So, muna ni siya. Ang vertex nato kung asa nag-meet ang atoang T1 ug kung asa nag-meet ang atoang T1. So kung sa V1, asa nag-meet ang atoang T1, mo ni ang atoang vertex. So muna diri atong vertex. Same thing sa atoang V2, kung asa nag-meet ang atoang length of tangent of the second curve, mo pud niya ang atoang vertex dari. Kani. Kasi sila nag-meet. Next is we have the I1 and the I2. It is the central angle of the curve. So, muna nga to ang I1 na to, ang kaninga angle. Napo dari sa obos, kani. Muna nga to ang angle sa to ang curve. Now, we have the I. It is the angle of intersection. So, kung asa mag-intersect ang ato ang back and forward tangent, diri ang ato ang angle of intersection. Diri nga part. Kani. I is equals to I1 plus I2. I-add lang nato. Next is we have LC1, LC2. It is the length of the first curve and the length of the second curve. Ang ato ang LC1 is kani nga curve. Kani nga curve ni siya. Ato ang LC2 is kani nga blue dari sa pikas. Mo nga ato ang LC2. So moving on. So ato ang L1, the length of the first chord, the length of the second chord, the length of long chord from PC to PT. So asa man ni ang chord nato? Located. Ang chord nato is kani. Mo nang tawag nila kani ang chord. Kani, tapos kani. Mo na nga to ang chord. So kung L1, mo na nga to ang length sa to ang first chord. Ang kani nga part. Kani siya. Pag sa L2, mo na nga to ang length sa to ang second chord. And so kung sa L, mo na ang length nato from PC to PT. Mo ni siya kani nga part. So, muna yung mga formulas nga pangkwao na to. Kani. So, kani. Moving on, we have this stationing sa PT. Ang pagpangita sa stationing sa PT. We have two ways. Kung given ang station sa PC or kung given ang station sa PT. Mani. So, ang formula nato sa pagkuha sa PT, kung present ang atong PC is this. So, station PC kani plus station na noon plus LC1 and LC2 kani plus LC1 and LC2. So muna siya ang formula sa pagkuha nato sa PT. So kung given pud ang station sa PI andiri ang sa vertex niya mo pud ang formula sa pagkuha sa PT. So station PI so atong PI nato na ari minus ang ato ang X kani nga to ang X minus T1, ang kani nga tong T1, kani nga T1 plus LC1, kani nga LC1 plus LC2. So, mura siya ato ang formula sa pagkuha sa ato ang station PT. So, with that, let's have a one sample problem. So the compound curve has the following elements. We have the I1, which is 25 degrees, I2, 40 degrees. We have the D1, 3.5 degrees, and our D2, which is 6 degrees. So if the vertex is at station 3,470.5, what is the station at PT? So, ano, itong problem na to, muna ang mga given values. Okay. So, muna yung ato ang diagram na to. Muna yung ato ang back tangent, as I said earlier. Muna yung ato ang forward tangent. Ang giingon ganiha is, ato ang vertex is nasa station 3,470.5. So, diri man ang ato ang, wala. So, diri man ang ato ang vertex. So, therefore, diri ang ato ang station 3,470.5. So, ano ta dari? So, we have to analyze first what values are we going to get for us to get the PT. Dili kay mag-solve lang tag unsa-unsa diari. So, i-analyze na nato pag unsa nga mga values ang kinahanglan para makuha nato ang station PT. So, for us to get the station PC, we have to get first station PC nato ug ato ang L1 ug ang L2 or LC1 and LC2. So, pagkuha sa tong station PT, we need ato ang station PC, our length of the first curve, and our length of the second curve. However, dili man po given ang ato ang L1, L2 ug ang station sa PC. So, of course, isolve pa nato na sila. Diba? So, for us to get the station of PC, so for us to get the station of PC, we have to solve ang kaning sa vertex niya og ang ato ang pagkuha sa tuang tangent 1. Atong first tangent, atong pagkuha sa station PC. Ang pagkuha sa atong L1 ug ang sa atong L2 kay we need to get our tangent 1 and tangent 2 also. For our first tangent of the curve of our second tangent of the curve. So, ang pagkuha sa tuang first tangent ug ang atong second tangent is pagkuha sa tuang R1 ug ang sa atong R2, di ba? So, ang pagkuha nato the values that we're going to get sa pagkuha sa atong station PC is R1 is R2, first tangent of the curve kani, second tangent of the curve ato ang station PC, our first length of the curve, and then our second length of the curve. So, mo na tong pangitaon para makuha nato ang station PC. So, sugod ta. Ang given nato is ang I1, which is 25 degrees, our I2, which is 40 degrees, our D1, which is 33.5 degrees, our D2, which is 6 degrees. So, we have the formulas right here. It was explained earlier sa simple curve kung asa gikan ning 1,145.316 over D. So, ang sa tuwa diari, we just have to plug in the given values. So, ito ang R1, which is ang kani nga R1 is equals to 1,145.316 over our D1. What is our D1? 3.5. So, kung we are going to plug it sa ato ang calculator, we will have a value of 327.405 meters. Okay? Kuhara. Next is our R2. Kani nga R2, which we have 1,145.316 over our D2. What is our D2? Which is 6 degrees. So, plug in sa calculator ang kani, we'll get a value of 190.986 meters. So, moving on, we have to get our T1 and our T2, our tangent of the first curve and our tangent of the second curve. So, muna na to ang formula na to. We have T1 is equals to R1 tan times I1 over 2. Muna siya. Then, same thing sa to ang T2. So, we just have to plug in the values. Atong R1, which is 25 degrees, and then tan Tapos, ato ang I1, ay no, sorry. Ato ang R1, which is 405 meters. And then tan times our I1, which is 25 degrees over 2. So, kung ato na siyang i-plug in sa itong calculator, we will get the value of 72.583 meters. So, muna ato ang atong tangent of the first curve. Same thing sa ato ang T2, ato ang R2, which is 190.986 meters. And then tan, ato ang I2, which is 40 degrees divided by 2. So, we will have a value of 69.513 meters. Next is ang pagkuha nato sa kaninga length. Kaninga length diari. Kani, ato ani siyang kwaon para makuha nato ato ang station of PC. Ang kani. So, for us to get kaninga length, we will have to use a sine law. Sine law. Why? Kasi given naman ang ato ang duha ka angle. Hatag na ang duha ka angle na natay angle diri sa pikas, naa na pugid tay length sa tuang T1 ug T2, di ba kani? Ato ara siyang i-add para naatay length di ari nga side. So, diri let us diri ta magamit sa tuang diri ta mag-visualize sa tuang solving. So, ang kaninga side is, let's call it A. Ang kaninga side, dare. Ang kaninga side. Let's call it A. Ang dininga side, diri B. Atong tawag na to, ang kanidiri, mo niyang B. And then, ang sa other, sa ubos na to nga side is our T1 and the T2, which is given na. Ito na na-solve. Ang diri nga part, ang angle di ari, let's call this beta. So, saan man na to pagkuha sa angle di ari? So, let us refer here. So, since this is triangle, of course, we have to use 180 degrees. And then, minus 25 degrees ang kani, minus 40 degrees ang kani. So, kung 180 degrees, minus 25 degrees, minus 40 degrees, so we will have a value, we have the angle of our beta, which is 115 degrees. Okay? So, muna rin siya. First is we have to add our T1 and T2. So, 72.583 meters plus 69.913 meters is, we'll have a value, we have the length of 142.097 meters. So, diri na. I know guys, kabalo na mga nagiyon sa ni siya diari. So, first is we are looking for the A, di ba? Ang kaatbang sa A nato is 40 degrees. So, we will write sine 40 degrees dire. So, A over sine 40 degrees is equals to our T1 and T2 right here is 142.097 meters. Buta na to dari. Muna ni siya. Ang kaatbang ani niya, so may kaatbang sa itong T1 ug T2. Di ba nga to ang beta? So, buta na to dari sine 115, which is our beta. Nakuhara. Ang giyon sa ni siya. Next is we have to do a cross multiplication ng kani. So, cross multiply nato sine 40 degrees times 142.097 over sine 115 degrees. So, i-plug in nato sa tong calculator, we will get a value of 781 meters. So, mo nato ang A nato. A ra man atong pangitaon, di na ta mag-solve sa to ang B. So, mo natong A. Dire ang ato ang A. So, now we can solve our station of PC. It was, ang kaning 3,470.5, it was given earlier na, di ba? Andire nga sa to ang vertex nato. So, 3,470.5, i-minus nato sa to ang A, ang kaninga A, which is 100.781 meters, plus our minus our tangent of the first curve, which is 72.583 meters. So, ito siyang i-solve. 3,470.5 minus 100.781 minus 72.584, it will give us a value of our station PC, which is 3,297.135. So, muna na itong station PC. Na-solve na nato. Next is we will look for our length. Ang kaning length nato sa tuang curve. Ang kani siya. para makuha na to ang station PT. So, muna to ang formula ganiha nga giderive sa simple curve nato nga discussion. So, we have L is equals to I times our pi over 180 degrees times our radius. So, we were looking for our for our L1 and L2. So, muna tong formula nato kani. L1 is equals to I1 times radius 1 times pi over 180 degrees. Our L2 is I2 times radius 2 times pi over 180 degrees. So, muna ito ang formula nato. So, we will just going to plug in the value since kompleto naman tanan nga to ang mga gipang solve. L1 is equals to I1, which is 25 degrees. Our R1, our radius 1 is 327.405 meters times our pi over 180 degrees. So, if we plug in ito sa itong calculator, we will have a length of atong first curve, atong length of the first curve, we will have a length of 142.857 meters. So, muna ni siya, isa, atong length 1. Next is we have our length 2. I2, we have 40 degrees. Our R2, which is 190.986 meters. And then pi over 180 degrees. So, plug in sa atong calculator. 25 degrees times 190.986 meters times pi over 180 will give us a length of 133.333 meters. So, muna na ito ang L2. Now, nakuha na nato ato ang station of PC, our L1, and our L2. Now, we can get our station of PT na dayon. Kani. Given na nga to ang station of PC, given na nga to ang L1 ng kani, and then given na to ang L2, which is kani. So, makuha na nato ato ang station of PT. So, we're just going to add ato ang station of PC, which is 3,297.135 plus our L1, which is 142.857 plus our L2 kani, which is 133.333. Plug in sa itong calculator, add na to. So, it will give us a value sa itong station of PT, which is 3,573.325. So, muna na ito ang station of PC. Diba? Mamalang ipangayo, what is the station at PT? So, that is how you're going to get the station of PC. So, yung anira siya, we have to analyze unsang ang kwaon ni mga values para makuha kung unsa gid ang gipangayo nga problem sa imo. Okay?
So this is the reverse curve. A reverse curve is composed of two or more simple curves turning in opposite directions. Their points of intersection lie on the opposite ends of a common tangent, and the PT of the first curve is incident with the PC of the second. This point is called the point of reverse curvature. So as you can see here, these are the two curves, the curve here and the curve here. The part or the point where they coincide or they meet is called the PRC or the point reverse curvature. Elements of a reverse curve. PC is equals to point of curvature, PT is equals to point of tangency, PRC is equals to point of reverse curvature, like I said in the previous slide. T1 is the length of tangent of the first curve from PC to the first vertex to the PRC. It connects in a straight line like this or in a triangle. While the T2 is the length of tangent of the second curve from PRC to the second vertex to the PT. V1 is the vertex of the first curve. V2 is the vertex of the second curve. I1 is the central angle of the first curve, which is right here, wherein I2 is the central angle of the second curve which is over here. LC1 is the length of the first curve, the length of the curve itself from PC all the way to PRC, while the LC2 is the length of the second curve from PRC, the curve, all the way to PT. L1 is the length of the first chord. L2 is the length of the second chord. The formula T1 plus T2 is equals to the length of common tangent measured from V1 to V2. This from V1 to V2. From here all the way to here. In finding the stationing of PT, given the stationing of PC, STA-PT is equals to STA-PC plus LC1 plus LC2. Given the stationing of V1 STA, PT is equals to STA V1 minus T1 plus LC1 plus LC2. Reverse curve for parallel tangents. Like as you can see here, the back tangent and the forward tangent are parallel to each other. If we continue this here, we continue this here, they are parallel to each other. Reverse curve for non-parallel tangents. So this is the example of a reverse curve for non-parallel tangents. As we can see, the back tangent is a straight, while the forward tangent proceeds to turn at an angle over here. So instead of going straight, it moved inwards.
So let's try to solve one problem. A reversed curve with diverging tangent is to be designed to connect to three traversed lines for the portion of the proposed highway. The lines AB is 185 meters, BC is 122.40 meters, and CD is 285 meters. The azimuths are due east, 242 degrees, and 302 respectively. The following are the cost index and specification. So the type of pavement is item 311, Portland cement concrete pavement, number of lanes 2 lanes, width of pavement 3.05 meters per lane, thickness of pavement 280 millimeters, and unit cost 1,800 pesos per square meter. Take note that the PRC or point of reversed curvature must be 1/4 the distance BC from B. So find the radius of the first curve. Find the length of road from A to D using arc basis, and find the cost of the concrete pavement from A to D. Before we proceed in finding the radius, we still need to find the tangent length of both curves. We have the given formula, which is 1/4 multiplied by BC. Substituting the value for BC, we would have 1/4 multiplied by 122.40 meters. The answer would be 30.6 meters for the tangent length of the first curve. To get the tangent length of the second curve, all we need to do is subtract 122.40 to 30.6, which gives us an answer of 91.8 meters. Since we already have the value for the tangent length for the first curve, we may proceed in solving for the radius of the first curve. In computing the radius, we have tangent length of the first curve over tangent of 14, y14. Based on the figure, this is our radius 1. So we have an angle of 14 degrees, diba? So, mauto 14 degrees ang gigamit. So, 30.6 is our tangent length over tangent of 14. So the answer is 122.73 meters. So the radius for the second curve, so 91.8 kani over tangent of 30. 30 kay here, as you can see, second radius 30 ang angle. So 91.8 over tangent of 30 degrees is equals to 159 meters. To find the total length of road from A to D, we have 154.40 from point A to PC. So same ra dere, 154.40. plus 2 pi multiplied by the radius of the first curve, 122.73, multiplied by 28 degrees over 180 degrees, plus pi multiplied by radius of the second curve, 159, multiplied by 60 degrees over 180 degrees plus the length from PT to D, which is 193.20, same raman. Overall, we would get an answer of 574.08 meters. Lastly, to find the cost of the concrete pavement from A to D, before that, we first need to find the area of the road pavement. So the area of the road pavement is equals to the length from point A to PC, which is 154.40, multiplied by 6.10, this one, the height, plus plus pi multiplied by 119.68 plus 6.10 squared minus 198.68 squared multiplied by 28 degrees over 360 degrees plus pi multiplied by 155.95 plus 6.10 squared minus 155.95 squared multiplied by 60 degrees over 360 degrees plus the length from PT to D, which is 193.20 multiplied by 6.10 plus another 193.20 multiplied again by 6.10. So 160.50 plus 365.86 plus 1015.68 plus 1178.52. So the area of the road pavement is 2720.56 square meters. So now that we have the area, we can already solve for the cost of the concrete pavement. The cost is equals to the unit cost, which is 1,800 multiplied by the area, or simply 2,720.56. Thus, the overall cost is 4,897,897,008 pesos.
Vertical curves. They are used to adjust the road slope, and it can be symmetrical or asymmetrical. Vertical curves are not circular like horizontal curves, but rather parabolic. The main design criterion of the vertical curve is to determine the proper grade and safe passing sight distance. The length of the crest vertical curve should be sufficient to provide safe stopping sight distance, while the length of the sag vertical curve is important because it influences factors such as headlight sight distance, rider comfort, and the drainage requirements. So this picture is an example of symmetrical parabolic vertical curve. It is called symmetrical because the curve is made up of a single vertical curve. So these are the elements of vertical curve. PC, point of curvature, also known as BVC, beginning of vertical curve. PT, point of tangency, also known as EVC, end of vertical curve. PI, point of intersection of the tangents, also called PVI, point of vertical intersection. Excuse me. L is length of parabolic curve. It is the projection of the curve into a horizontal surface which corresponds to the planned distance. S1, horizontal distance from PC to the highest point of the summit or sag curve. S2, horizontal distance from PT to the highest point of the summit curve. H1, the vertical distance between PC and the highest point of the summit curve. H2, vertical distance between PT and the highest point of the summit curve. G1, grade in percent of back tangent, the tangent through PC. G2, grade of forward tangent, tangent through PT. A, capital A is the change in grade from PC to PT. Small a, vertical distance between PC and PI. B, vertical distance between PT and PI. And last is H, the vertical distance between PI and the curve. So let's have a sample problem. A vertical summit curve has tangent grades of positive 2.6% grades and negative 1.5%. Using h1 is equal to 1.37 meters and h2 is equal to 0.1 meters. Calculate the minimum length of the curve if the required sight distance is 137. So in this particular problem, its goal is to find the minimum length of the curve, which is the parabolic curve. And the key to find its sight distance is using a formula. The first step is to know the given. Next is to assume that the sight distance is greater than compared to the length of the curve. So first, let's assume that sight distance is greater than the length.
Unsymmetrical parabolic curve. Using two or more parabolic curves placed adjacent to each other is called unsymmetrical parabolic curve. So this is a problem of unsymmetrical parabolic curve. A negative 4 grade at STA 5 plus 700 and at elevation 110.2 meters is to connect to a positive 6% grade at STA 6 plus 100 at elevation 105.2. Determine the following: elevation and grade of PCC or point of common curve and the location of the PVI of the vertical intersection. Since in order to get the elevation and grade of the PCC, we need to solve for the location first of the PVI, which is this one over here. So here we have 0.04 L1 is equals to 0.06 L2 plus 5. So how did we get this? So we got this because since slope is rise over run and we have the gradient given, which is negative 4% and negative 6% at L1 and L2, therefore we need the elevation is the product uh, of the gradient by the L, which is 0.04 L1 and 0.06 L2. So this is how we got this. 0.04 L1 is equals to 0.06 L2. We placed plus 5 because there is a vertical offset of 5 meters. So here we substitute them. 0.04 L1 is equals to 0.06 multiplied to the quantity of 400 minus L1 plus 5. Why did we substitute L2 as 400 minus L1? Since L is given, which is 400 meters, L2, the formula for L2 is equals to VL minus VL1, which is 400 minus L1. So this is the reason why we substitute this here. So if we solve it, L1 is equals to 290 meters and L2 is 110 meters. So to get the elevation of PVI, we need to substitute the elevation for A, which is 110.2 minus 0.04, the gradient of the slope times 290 is equals to 98.6 meters. So the elevation of the PVI from here is 98.6 meters. So we need to get the location. So in order to get the location, we just need to add STA 5 plus 700 by 290. Therefore, we have STA 5 plus 990. Since we already got the location of the point vertical intersection, next we need to get the grade of the PCC. So we all know that the tangent the tangent line always meets halfway of the parabolic curve. So these two here are two different parabolic curves. So it is understood that L1, since they are both located in the middle, there is a line. This separates to L1 over 2 and L2 L1 over 2 here. Here, this part over here and this part over here. Same with the other side. The tangent line always meets halfway. So um, separating the two, so therefore this is L2 over 2, this over here, and this over here is also L2 over 2. So we need to get the third grade. So this is how we get it. 110.2, which is the elevation of A, minus 0.04, because it's descending or going down, uh, times 290 divided by 2. Why 290 divided by 2? It's because we separated it here at the tangent line. We use this L1 over 2 plus G3 is 200, because in between here, this here, in between this over here is L over 2, because if we add L1 over L1 plus L2 over 2, it will give us to L over 2. So L over 2, where L is 400 meters, will give us 200. So that's why it is G3 multiplied by 200, because the L over 2 is equals to 200, plus 0.06 times 55. Why 55? Because if we divide 110, the L2 divided by 2 is 55. And we have a positive 6% gradient is equals to 105.2. Doing all the necessary computations, this will give us to negative 0.0125 or negative 1.25%. Since we already have the grade of the G3, which is negative 1.25%, looking at here the grade diagram, so this is the grade diagram wherein L1 290. This is the area at 0.04 grade and 0.06 grade. As you can see here, this here is the lowest point. So we need to get the elevation of this. So to get the elevation, we need to add 0.04 plus 0.0125 and you get the half of it, multiplied by 290, which is here, because the PCC is under here at this part. So doing all necessary calculations, we have 7.613 meters. So this 7.613 meters, we will subtract it from the elevation at A, which is 110.2, which will give us the elevation of PCC at 102.587 meters. So now we have the elevation and grade of PCC, or the point of common curve, which is negative 1.25% and 102.587 meters.
Stopping sight distance is the minimum sight distance along the road at any spot having sufficient length to enable the driver to stop a vehicle traveling at designed speed safely without collision with any other obstruction. It is also termed as non-passing sight distance or non-overtaking sight distance. In addition, the stopping sight distance is the sum of the braking distance and the lag distance. In other words, it is the length of roadway that should be visible ahead of you, in order to ensure that you will be able to stop if there is an object in your path. Stopping sight distance is an important factor in traffic engineering, and it depends upon the following factors. First is a feature of the road such as the horizontal alignment, vertical alignment, traffic conditions, and position of obstructions. Next is the height of driver's eye above the road surface. And lastly, the height of the object above the road surface. The stopping sight distance is comprised of two components, the lag distance and the braking distance. The lag distance is the distance traveled by the vehicle during the total reaction time. It has a formula of V times T, where V is the design speed in meters per second and T is the total reaction time of the driver in seconds, which has a fixed value of 2.5 seconds.
Analysis of SSD or stopping sight distance. The stopping sight distance is comprised of two components. First is the lag distance. It is the distance traveled by the vehicle during the total reaction time. Lag distance is equal to V times T, where V is equal to design speed in meter per seconds, while T is equal to the total reaction time of the driver in seconds, which is equivalent to 2.5 seconds. If the speed is V km per hour, then the formula is SSD is equal to 0.278 V times T plus V squared over 254 F. These formulas are applicable for stopping distance on level road. So the table here is the recommended longitudinal coefficient of friction values for providing SSD.
So let's have a sample problem sa to ang stopping sight distance. So one, we have calculate the safe stopping sight distance on a level road for design speed of 50 kilometers per hour for A, two-way traffic on two-lane road. B is to find a two-way traffic on a single lane road. So we have to assume that our coefficient of longitudinal friction is 0.37 and our reaction time sa driver as 2.5 seconds. So muna itong given na to. We have the given here, our V or the design speed, which is 50 kilometers per hour. So we can convert it to meters per second. Diba? Pwede na to siya ma-convert. We have V is equals to 50 kilometers per hour times 5 over 18. So we will going to have a value of 13.89 meters per second. Ang kani naka-kilometers per hour ni siya. Ang kani di ari naka-meters per second. Next is we have a time. We have our reaction time sa driver which is 2.5 seconds. Our friction 0.37 and of course our gravity which is 9.8 meters per second squared. So muna itong given values. So next, okay, this is our solving calculation. So kani nga part di ari mo na tong formula for meters per second squared. Kani. Ang diri sa pikas nato mo na tong formula sa pag ang atuang design speed or pag atuang V is in kilometers per lagi is in kilometers per hour. Diba? It says here di ari nga ang kani nga formula pag atoang pag atoang V, pag atoang V is naka meters per second squared and pag diari pag atoang V is in pag naka kilometers per hour siya. So, okay, we just have to plug in the values since kompleto naman po siya tanan. Our V in meters per second which is 13.89 times our reaction time which is 2.5. So plus our V still 13.89 squared over 2, atong 2 dari is constant na, times our gravity 9.8 and times our friction which is 0.37. So multiply na to 13.89 times 2.5, plug in sa atong calculator, then we will have a value of 34.72. So diri sa pikas, 13.89 squared over 2 times 9.8 times 0.37. So plug in sa itong calculator, we will have a value of 26.60. So kung i-add nato na siya duha, 34.72 plus 26.60, it will give us a length of 61.32 meters. So mo na yung ato ang safe stopping site distance. So diri sa pikas pareha lang atong ara gyapon siya i-substitute sa mga atong substitute na to atong mga given values sa ato ang formula. So we have here 0.78V. So kung wonder kung asa gikan ni siya, constant na ni daan na ni sa tuang gikuan ganiha. Kani 0.70 278 ug awong ato ang 254. So, mananin siya. 0.278 ato ang V, which is 50 kilometers per hour, times our reaction time, which is 2.5 seconds, plus our V, our design speed in kilometers per hour, which is 50 squared over 254 times our friction, which is 0.37. So, ato na siya yung sa itong calculator. 0.278 times 50 times 2.5, it will give us a value of 34.75. So, there is a pikas 50 squared over 254 times 0.37. Plug in sa itong calculator, it will give us a value of 26.60. So, i-add natin siyang duha. 34.75 plus 26.60 will give us a value of 61.35 meters. So, di ba? Same ra sila. Pero kwaon na to ang kaasang mas dako og decimal point. So, ang atong answer sa tuang A, we have the two-way traffic on two-lane road is we have 61.35 meters. Ano yun siya? Ang atuang sa two-lane road. Ang atuang sa single lane road is we're just going to multiply it to 2. So 2 times 61.35, it will give us a length of our safe stopping site distance on a single lane road, which is 122.7 meters. So, ani ra siya kadali ang atuang safe stopping time.
Features of route survey and design. Some features that are included consist of the following. First is locating the center line by placing stations at an interval. Second, determining elevations along and across the center line for plotting profile and cross sections. Third, plotting the profile and cross sections and fixing the grades. Fourth, computing the volumes of earthwork and making a mass diagram. Fifth, staking out the extremities for cuts and fills. Sixth, determining drainage areas to be used in the design of ditches and culverts. Last is laying out structures such as bridges and culverts, locating right-of-way boundaries as well as staking out fence lines if necessary. Location survey. It is to set out work on the ground for actual construction or execution of the project. It is also the establishment on the ground of points and lines in positions which have been determined previously by computation, by graphical methods, or by a description obtained from data supplied by documents of records such as deeds, maps, or other sources. The objectives of location survey is to determine the relative position of any objects or points of the Earth. It is also to determine the distance and angle between different objects, and to prepare a map or a plan to represent an area on a horizontal plan.
Factors to consider in design of highway. Highway geometric design refers to the study and calculations done by engineers when it comes to roadways. This is done to guarantee that the highway is designed to meet the topography of a specific location while also ensuring service, performance, and safety. There are various factors that must be considered when designing a roadway, including design traffic volume. The traffic volume is the average density of traffic that will run on a road in an hour of every day. With the help of these volumes, service flow rate and other calculations will help determine how the road should be constructed. Level of service. Level of service refers to the qualitative measure of functional conditions within traffic stream. This is commonly described as freedom to maneuver, travel time, speed, comfort, safety, convenience, and interruptions. This criterion differs for multi-lane highways, and it is defined in density. Sight distance. This refers to the length of the road ahead that can be seen by the user of the roadway. Most of the time, specific distances apply to cyclists and motor vehicles. Design speed. This refers to the highest speed at which vehicles can travel on the road safely when the weather is favorable and the density of traffic is low, while ensuring that the safe speed is only determined by the road's geometric features. Roadway context. This factor will determine fundamental design decisions like the cross-section determination, detailed design elements, and street fixtures to name a few. A design that is context-sensitive will start with analyzing the contextual elements like the community and environment that surrounds the area. Once the designer clearly understands the surroundings of a potential highway and its users, the rest is much easier to design and plan. Lastly, safety. The safety that all transportation facilities provide is a primary consideration when it comes to geometric road design. While constructing roads, certain projects are specifically made to tackle existing safety hazards. It is important that all projects do eventually result in facilities that are extremely safe for its users.